Hi, Dave here. And today we're talking about Chapter 9 of Absolute Java by Walter Savage. And this is the first of 4 videos. The first video, this one, is just going to introduce exceptions. We'll look at try, catch, get used to different parts that make up an exception, but we're not going to really talk about any real-world examples. Video 2, we'll look at how to create our own exception classes. Video 3, we'll talk about the catch or declare rule. We're going to show that exceptions are usually caught in the calling method, but they're going to be thrown by the called method. We'll look at how to use JUnit4 to test our exceptions. And then video 4 will be some advanced usage to show that we can nest try-catch blocks within a try or within a catch block. There's a concept called finally, and we'll look at some techniques used to deal with bad user input. Now, sometimes the best outcome can be when nothing unusual happens. That being said, we still need to prepare when exceptional things do happen. And Java has provided us some exception handling facilities that are used when the invocation of a method may cause something exceptional to occur. For example, I/O. What do we do if we're trying to reference a file that doesn't exist or the disk crashes? Now, Java library software and also our own programmer-defined code provides a mechanism that can signal when something unusual happens. This signal is going to be what we say is throwing an exception. And when an exception is thrown, in another place in our program, we're going to have to provide code that can deal with that exception. And this is going to be called catching or handling the exception. I want to talk quite a bit about exceptions and exception classes. There is a class called exception in the java.lang package, so we don't have to import it. And I'm showing you the Java doc for this exception class here. And the main point of showing you this Java doc is for you to see all these subclasses of the exception class. And these classes in turn have descendants. So there are a lot of exceptions. In yellow, I show a couple that will come across more often than others. We're typically going to see I/O exception, and Joel's going to talk about that next week. We're going to see SQL exceptions when we use JDBC with SQL databases, and we'll see reflective operation exception when we try to use classes and the particular class can't be found. Now, the exception class has got a few constructors. The two most important, the two most visible to us, are going to be the no-arg constructor and then the one-arg constructor. The one-arg constructor is going to take a string that kind of describes what went wrong, what was the reason for the exception. In terms of methods, there are two most popular methods that we will see. First is the get message. It's the getter, it's the accessor to get that string that we passed the one-arg string constructor. And there's also a print stack trace that will print to the error stream. So this is going to be that red message that you've seen come up in the Eclipse console window. That's going to describe the exception itself and also what led to this exception. A lot of times you'll see Eclipse automatically populate the catch blocks of your try-catch blocks with a print stack trace. So first, let's look at an example that does not use try-catch. We'll then put try-catch into it. We'll then talk about try and catch by itself and come back and relook at this example. So this is a dance lesson. We're going to see how many men are here, how many women are here. If we don't have any men, if we don't have any women, if we don't have either or, we can't hold the lesson. So we're going to ask for the number of men. We'll ask the number of women. If we don't have men or women, game over. We'll show a J option pane, and then we'll do a system exit. If there's no men, we'll explain that the lesson's canceled, do a system exit. If we have no women, we'll cancel, do a system exit. Otherwise, we'll talk about how many men and women are paired up. Here's that same example with the try-catch block inserted. We start off by asking how many men, how many women. And then we enter this try block, showing the beginning and the end in green. These are all the statements that we'd like to try. And if we're executing, and as we execute, if we come to a throw statement, and we execute a throw statement, it's going to immediately terminate the try block. It's going to jump all the way down to the catch block that you see in pink and execute the statements in the catch block, and then continue on with the J option pane, show message dialog. Now, if in the try block we never execute a throw statement, in other words, if all these if, else statements are false, we'll continue on, execute to the end of the try block, and then skip the catch block and execute the J option pane, show message dialog. So let's look at the try, throw, catch mechanism. The try block contains the code for the basic algorithm. It tells what to do when everything goes smoothly. It's called a happy path. And you're going to see the nice thing about the happy path is eventually we'll not have to embed a lot of error checking in there. It's just going to be the code assuming that everything works properly. It's called the try block because it tries to execute the case where all goes as planned. Now, it can also contain code that throws an exception. And you can see it here. It's called throw new exception. So it's throwing an instance of an exception. And that instance is going to have passed to it a one argument string unknown student. Now, instead of doing it in one line, I could have done that in 2 lines. I could have created an instance first of an exception, and then I could have given that instance to the throw operator. But this is very rarely seen. Typically, you're going to see it shorthand. And that shorthand is going to be the one I have here in blue. Throw an instance of an exception. Sometimes it appears clearer when you put parenthesis signs around the constructor that creates the instance, but this is very rarely seen. Now, when an execution is thrown, the execution of the try block is stopped immediately. Think of it like a break statement. The flow of control is transferred to another portion of code, which is known as the catch block. The value thrown is the instance. It's the argument to the throw operator. And it has to be an object of some exception class or some exception descendant. The execution of the throw statement is called throwing the exception. Now, you could say that the throw statement is similar to a method call. So throw a particular instance. In the above example, the object of class, exception class name, is created using some Elon string as its argument. This object is the argument to the throw operator and is the exception object thrown. So instead of calling a method, a throw statement kind of calls a catch block. And the catch block that's called will begin execution. The catch block will only have one parameter. So here I'm showing catch with the parameter E of type exception. The exception object thrown is plugged in for the catch block parameter, E in this case, only if it is of the specified type. And that type here is exception. The execution of the catch block is called catching the exception or handling the exception. And whenever an exception is thrown, it should ultimately be handled by some catch block. Otherwise, you're going to see the red error messages come up in the console window. Now, a catch block kind of looks like a method definition that has a parameter of type exception class, but it's not really a method definition. A catch block is a separate piece of code that is executed when the program encounters and executes a throw statement in the preceding, that's key, in the preceding try block. And a catch block is often referred to as an exception handler. Once again, it can only have one parameter. A lot of times you're going to see the parameter E used. There's nothing magic about this parameter. You can use any name that you like. And the catch block parameter does two things. It specifies the type of thrown exception object that the catch block can catch. Here I'm showing exception, but we could be more specific, maybe SQL exception, or IO exception, or null pointer exception. It provides a name for the thrown object that is caught, on which you can reference and you can operate on it in the catch block. Now, when the try block is executed, two things can happen, right? No exception is thrown. It's the happy path. We execute the entire try block. We get to the end of the try block. We are going to skip all of the catch blocks. And then after the catch blocks, we'll continue with our execution. However, something can go wrong inside the try block. And once something goes wrong and we see a throw statement, the rest of the code in the try block will be skipped. And control will be immediately transferred to a following catch block. The thrown object will be plugged in for the catch block parameter. We'll execute the code in the catch block, and then we'll continue after the catch block with any code. So back to our original example, here is our try block. If every statement executes in the try block, because we have both men and women, we will skip the pink catch block and execute the J option pane show message dialog. But if we're going through the try block and we have no men, no women, or just no men, or just no women, we're going to execute a throw statement. And once we execute a throw statement, we're going to immediately leave the try block, come down to the pink catch block, execute those statements, and then execute statements following it, which in this case is the J option pane show message dialog. Now, I've only shown one catch block. We could have multiple catch blocks. A try block can potentially throw any number of exception objects, and they can be of differing types. True that in any one execution of a try block, only one exception can be thrown because the throw statement will immediately end the execution of the try block. But on different executions of the code, perhaps we will go through different paths and get the different throw statements with different exception types. Now each catch block can only catch values of the exception class type given in the catch block heading. Different types of exceptions can be caught by placing more than one catch block after a try block. In fact, any number of catch blocks can be included, but we've got to be careful in what order we put them. Because when an exception is thrown, the catch blocks will be examined in sequential order from top to bottom. And the first one that matches the type of the exception thrown is the one that will be executed. Now, one nice thing is the compiler is going to force us to put those into the proper order. Here's a quick example, and I'm showing two different types of exceptions. I'm showing the negative number exception here early on in pink, and then down below I'm showing in green another type of exception called division by zero exception. And what we have for this more catch blocks demo is we're going to prompt the student for how many pencils they have and how many erasers they have. And if they have negative pencils or negative erasers, we're going to throw a negative number exception. If they have zero erasers, we're going to throw a division by zero exception. And the point here is as the user responds to the different prompts, for example, a negative pencils, they'll throw a negative number exception with the string pencils, immediately jump down to the negative number exception catch block, execute that, and then skip over the division by zero exception and continue on with system.out println end of program. Now we could go through the try block and we got positive pencils, zero erasers, in which case we're going to throw a division by 0 exception. We will immediately leave the try block, skip over the negative number exception because we're not a negative number exception. It will go to the division by 0 exception, execute the contents, and then continue on with the rest of the program. If we go through with positive pencils, positive erases with the happy path, we execute the whole try block and skip both catch blocks and go to the system.out print line end of program. If we have multiple exceptions, we always have to list those most specific to general, to less specific. So in this case, the compiler wouldn't let me put exception first. I would have to put negative number exception before exception. And Eclipse will ensure that we do that. That completes this video. Next video, we'll look at how to create our own exception classes.